Hi guys, and welcome to part 2. So just a few more examples. These are some of the ones I wanted to make sure that I worked out a couple examples of, just in case you guys don't happen to get all of the homework questions done, which I highly recommend, especially for this test, that you do all of them, not just the ones that are the bare minimum assigned problems. Because a lot of times you just need to work, especially with the symbols and things, a lot more just to get used to what's going on. So I wanted to work out a few more examples before I give you guys some time to work on the homework and the practice problems on your own. A car has 8 spark plugs, of which 2 are defective. Find the probability of locating both defective spark plugs in only 2 random selections. Assume the first selection is not replaced. So this is going to be pretty simple. When you started, there were 2 defective out of 8. So the probability you picked a defective one on the first draw was 2 out of 8. Then, since it was not replaced, there are only 7 left, and now there's only 1. So the probability of picking the second one is going to be a defective one is going to be 1 out of 7. So the probability that you're going to pick both defective spark plugs is going to be 2 out of 8 times 1 out of 7, and that's going to equal 2 out of 56. You will notice whenever we do these problems that are without replacement, the denominator keeps decreasing because, the things are not being replaced, which might help a lot of you guys. So these problems are generally pretty easy to do as long as you're just doing one thing at a time and things are not being replaced, just by remembering to decrease the denominator and changing the numerators where needed. All right, one that's slightly more interesting. At a party with 10 men and 12 women, 2 door prizes are awarded. Find the probability that both prizes were won by 2 people of the same sex. Assume the ticket is not replaced after the first draw. Go ahead and pause the video and try this one on your own, and I will meet you back here to go over the answer. The most important information in here are going to be the number of men and the number of women, and the fact that this is going to be done without replacement. This is not replaced after the first draw. So for the first winner, there are 2 outcomes. The first winner could be male, or it could be a man, or could be a woman. Now, since we're starting off with a total of 22 people, hopefully you got the probabilities for 10 out of 22 and 12 out of 22. On the second draw, again, it could be a man or a woman. It could be a man or a woman. If the first time it was a man. Now again, whether it was a man or a woman on the first one, all of the probabilities now are going to be out of 21. So all 4 of these probabilities are going to be out of 21. If the first winner was a man, there are now 9 men left. So it's going to be 9 out of 21 and 12 out of 21. If a woman won the first time, there's now 11 women left. There's still 10 men, but now there's 11 women left. So 10 out of 21 and 11 out of 21. Now, we're finding the probability that both prizes were won by 2 people of the same sex. So there's 2 ways that could happen. They could have been won by 2 men, or they could have been won by 2 women. So the first one, that they were won by 2 men, that's going to be that top branch there. So the probability that a man won and then another man won is going to be the 10 out of 22 times 19 out of 21, which is 90 over 462. The other way that this could happen is if 2 women won. To get the probability of that particular branch, again, that would be the very bottom branch. And finally, to answer the question of the probability that both prizes were won by 2 people of the same sex, I would need to add those branches together. And now you see the other reason why I tell you not to reduce. Because if these denominators were not the same, it would be a lot more difficult to add these numbers together and get a fraction that makes sense. So again, even if you want to put your final answer in decimal form, don't do it until the very end. You want to show all of this work, and then you can do 222 out of 462 equals, and then change it into decimal if you wish. All right, a few more for us to try on the back page, or the next page. According to a newspaper, there's a 50% chance of rain tomorrow in Chantilly and a 50% chance of rain in Centerville. Can we find the probability it will rain in both cities tomorrow? Now, there's a problem with this, because if I told you that it is raining in Chantilly right now, the probability that it's raining in Centerville has just gone up, because you already know that it's raining in Chantilly. In other words, these 2 things are not going to be independent. So you can't just multiply these 2 numbers together and expect to get an accurate probability that it will rain in both cities, because these 2 things are not independent. On the other hand, if we say there's a 50% chance of rain tomorrow in Chantilly and a 50% chance of rain in Los Angeles, I'm much more likely to believe that these 2 things are independent. Or, I mean, depending on how much you know about weather systems, it's possible that they're not, but we'll say that they're independent enough that it makes no real difference. So in this case, to find the probability it will rain in both cities tomorrow, assuming that these two things are going to be independent, we can just do it the way we have been doing it. The probability that it rains in both of those cities is going to be the probability it rains in one times the probability it rains in the other. So it's going to be 0.5 times 0.5, which is going to be 25%. That was just to remind you guys, be careful when you're looking at these problems because you're going to have to make some assumptions about independence. The next one is an example of at least one. Go ahead and pause the video and go ahead and try that question and check your answers when you get back. Hopefully you guys realize what the meaning of the sentence here. Approximately 5% of normal pregnancies will receive a positive result. So that means even though the pregnancies are normal, 5% of them are going to test positive for chromosomal abnormalities. So that means that they are actually normal, but they're getting a positive result. In other words, this is a false positive. So this test has a false positive rate of 5%. The complement of that they don't get a false positive. In fact, they don't get a positive result, and that's a correct result. So the probability of not getting a false negative positive, which is, I guess, getting a true negative, would be 1 minus that. The complement, which is 95%. Now, because this is an at least one question, what's the probability there will be at least one false positive? Hopefully you figured out that's going to be the same as 1 minus the probability of none. So it's going to be 1 minus 0.95 to the 100th power because there's 100 women, so you should have gotten 0.9941 or thereabouts. It's a very high chance you're going to have at least one false positive because there's 100 women. And finally, drug tests. This one I'm just going to work through with you. You don't have to do this one on your own unless you would like to. If you'd like to, go ahead and pause the video, but we're just going to work through this one together. So we have an employee here. Many employers require prospective employees to take a drug test. A positive result indicates that they use illegal drugs. So we started off, we have some employee, and we don't know the truth, but one of two things is true. Either they're using drugs or they are not using drugs. Now we are assuming that 4% of them use drugs, which means that 96% of them do not use drugs. Now this employee, whether or not they use drugs, they don't do drugs, is going to take a drug test, and one of two things is possible. Either they will test positive or they will test negative for using illegal drugs. Now there are two more numbers that are important to us here. It says the false positive rate is 5%. That means if someone actually is not using illegal drugs, there's still a 5% chance that they are going to test positive. This is a conditional probability because it's assuming that they do not take drugs. What is the probability that they test positive? So the false positive rate is 5%. The true negative result, I guess, is going to be 95%. The last piece of information they give us is that the false negative rate is 10%. In other words, if they're actually doing drugs, the probability that they will test negative for drugs is 10%. Which means the probability that it test positive is going to be 0.9. I'm going to multiply along each of these branches to find the probabilities of each of these, which I just went ahead and did. It's going to be these numbers. So now we're going to go ahead and answer that first question. Part A, it says, what percent of prospective employees will test positive? Well, there's two ways that could happen. They could test positive and they were actually using drugs, or they could test positive and that's a false positive. They were not actually using drugs. So to answer that question, what I'm going to do is I'm going to find the different branches that represent the outcome of testing positive, which is going to be the top branch, and the third branch down, and add those together. So what percent of prospective employees will test positive? Well, it's going to be those that test positive because they should test positive, and those that get false positives. And add those together. Part B, what percent of prospective employees who test positive actually use illegal drugs? So, sorry, I forgot to give an actual answer for this here. So that's a total of more than 8% that test positive. But Part B is saying, well, what percent of those actually use illegal drugs? Well, that's a different question. That's a conditional probability. Of those who test positive, what percent of them actually use illegal drugs? So what's the probability they actually use drugs given that they just tested positive? So again, that's going to be drugs and test positive over testing positive. that is going to be 0.036 over 0.084, which is going to be something like 42.65%. All right, for this last question, it's a pretty simple one. You shouldn't have any trouble with it. Pause it, go ahead and do that one and check your answer when you get back. This is one of our favorite kinds of questions, at least one. Remember, the complement of at least one is none. So hopefully most of your guys' answers look like this. You realize that the probability of at least one is going to be 1 minus the probability of none, which is going to be 0.28 times, or 0.28 to the 5th power, because of course the probability that they are unlisted is 0.28. So you end up with a very high probability, 0.9983. And that's all I really have. Again, there was not really much that was new here. I just wanted to take the opportunity to work through a few different kinds of examples. Hopefully you were working along and were able to get these correct before you checked your answers. And if not, I'm hoping that the answers actually did make sense. So now that we've had a review, go ahead and use the rest of the period to check, to go back and check over these, make sure you have all your notes correct, and then go ahead and finish up the rest of your practice problems, the homework problems. Please, please, please use your calculator, use your formula sheet, use whatever resources you would have during an actual test to do these. Check your answers. I will answer questions on any of this before we start the test next class. All right, good luck, and I'll see you guys soon.